In part A of example 2, they ask us to find an expression for the area of the kth rectangle that we found in the previous problem. And so we're going to expand this and see if we can actually do just that. We'll find that expression in terms of n, and then we can substitute n equals 4 or n equals ever how many we have. But to actually do that bit of algebra with this summation, there are a couple of things that we need to know. So the first thing that we need to know is what the sum of k equals 1 to n of 1 is. Now, this is something that if you think about sigma notation, it's pretty straightforward, but this can really be mysterious the first time you look at it and think about it if you're not very comfortable with sigma notation. And so it helps to actually, anytime you're given a sum like this, it helps to actually start writing out the sum. So what would this look like? Well, it would be 1 and then plus, because it's a summation, and then what would I add? Well, you add what's here. So this would be 1 again, plus, and then I would have to add another 1, plus, dot, dot, dot. And you know what? The very last thing that I add is also going to be a 1. So I'm just adding ones. That's all I'm doing. The question is, what is this? How do I add up all of these ones? I don't even know how many there are. Well, let's count them. That's what this counter does. And so when k is equal to 1, we get this one. When k is equal to 2, we get this one. When k is equal to 3, we get this one. And when do we get this one? Well, we get the last one whenever k is equal to n. Now, if you think about multiplication of natural numbers, and this works for natural numbers, but not necessarily other types of multiplication or multiplication with other sets of numbers. You can think of multiplication as repeated addition, which is exactly what we have here. And so if I take 1 and I add it up, and I have n of those ones that I add, then that means that I have n times 1. I have a tendency to make my n's look like u's. So n times 1. Well, n times 1 is just n. And so this gives us our first little theorem for sigma notation. The sum from k equals 1 or to n of 1 is equal to n. So put a little cloud around that, and we can use it to help us simplify more complex solutions. So the next one actually has a little bit of a story with it. If you poll mathematicians, who's the greatest mathematician who ever lived? It's not Isaac Newton. It's not Gottfried Leibniz. So calculus in and of itself is not enough to win anybody that accolade. What it boils down to is who actually contributed the most to mathematics, and that means being prolific in terms of proving theorems. If you ask people that have PhDs in mathematics, who's the greatest mathematician? It always comes down to one of two people. It's either the Swiss mathematician Leonhard Euler or the German mathematician Carl Friedrich Gauss. And so one of the stories about Gauss when he was in primary school in Germany is that his teacher gave him the following problem. He was told to add. They had just been working on arithmetic, and so to get proficient at this, he wanted them to have some practice. Add the first 100 natural numbers. So Gauss, and again, he was like 7, 8, maybe 9 years old, looked at this problem. And he immediately recognized that if he added 1 and 99, he would get 100. If he added 2 and 98, he would get 100. If he added 3 and 97, he would get 100. And so if he continued in this process, he would just have pairs of numbers that would all add up to 100. And just like our counting principle up here, if you think of repeated addition, in this case 100 plus 100 plus 100, as multiplication, you only need to know how many of these pairs there are to find out how many hundreds you have. So the question is, how many pairs are there? Well, as he worked towards the middle, he realized that you have 49 plus 50 plus 51, and the last pair that he would add would be 49 plus 51. So how many pairs, how many of these 100 pairs are there? Well, there was 49, and so that sum was 49 times 100. So he needed only to add to this extra 100 and also this leftover 50. Okay, so again, thinking about basic arithmetic, if you've got 49 100s and you add another 100, that's going to be 50 100s. And so 50 times 100 is 5,000 plus 50 is 5,050. And this is the answer that Carl Friedrich Gauss brought to his elementary school math teacher on the 19th century chalk slate that he had at his desk. Now what's interesting about this is maybe it could be generalized. So here we've done the first 100 integers. But what would happen if we wanted to know the sum of the first n integers? Well, the first thing that we might consider doing is replacing 100 with n. And if you think about it, the other number that we had up here was 50, but 50 is clearly half of 100, so perhaps this would be n over 2. And so that means this would be n over 2. And if we multiply, we get n squared plus n over the common denominator of 2. And if you factor an n out, you get n times n plus 1 over 2. Now, I've not proven this. You can prove this. The proof of this uses something called mathematical induction, which comes from number theory and is beyond the scope of this course. So I feel somewhat justified in giving this to you just as a theorem that you can use. Just commit to memory. K equals 1 to n of k, our counter. So this is a very compact way of saying find the sum of the first n integers. So using sigma notation. So that is equal to n times n plus 1 over 2. And we can put a little cloud around that. And that is a theorem that we can use to simplify our Riemann sums. Interesting side note, Riemann sums are named after Bernard Riemann. He actually, this is work that he did for his dissertation, for his doctorate at the University of Göttingen. Interestingly enough, his supervisor, his major advisor for his research was none other than Carl Friedrich Gauss. We'll see you in the next video.